Okay, so here I've just connected my ESP32 with a laptop, and I'm ready to start my custom Python script that is going to be uploading the paper tape format to here to the emulator. So I'm going to be, so first I need to type L here, and now K1 is waiting for the paper tape format input. So I'm going to be uploading my 6502 chess program like I usually do. So let's start by, this one. The first is 000 paper tapes. It consists of 3 parts. And now here I just press enter. And you see like it starts uploading. And on this side is actually receiving. So we can say that these computers are connected in the network of some sort. Okay, so it's quite fast, and that's why I really love it so much. So now, let's say L again. So now it's loading for the next chunk, and here, it's 100. So okay, so enter, and starts uploading the second chunk here. And finally, the very last but not least is the main plane module, which is this one. Okay, so now we're gonna be able to play some chess. Okay, and now if I go to 3F6 space and G. So here is the print board routine, one of my favorite ones. So you see like the uppercase letters are white pieces, the lowercase are black pieces, and this number, it's not saying that nicely, but it's 8. I mean, right over in here it's 8, which means this is currently white to move. So in order to make the move, you need to alter the memory, and I've been demonstrating a whole lot of times already, like how that can be done. So we can say like 0, 1, 2, 3, 4, 5, 6, 60, 61, 2, 3, 4. So for instance, 64 goes to 44. So how can I do that? If I say 64, and we have 0, 9 there, which means we get a pawn. So if I just say 0, 0 to erase that, and then I go to 44 and 0, 9 to put a pawn there. And then I go to BC, which stands for side to move, and there I say 10, so that the engine would be searching, 0, 0 BC, 10, like this. So now engine is going to be searching for blacks, but just to make sure that it didn't mess up anything and made the move properly, if I go to 3F6 and G again, so I just made a move with a pawn. This is good. So I have 10, which means that black is now to move. One last thing, if I go to 201 here, we have the search depth. 3 is a little bit too long. However, it works much faster than on Arduino Mega, and even faster than on my JavaScript emulator. So let's consider like, let's make it 2, 0, 2, and store, and then 200s and G. And this makes engine start searching. So it's currently searching and it outputs the best move quite fast. Okay, so we can proceed the following, like we can proceed exactly the same way like we did before, but let me just show you how it plays itself. So I would be going to 200s and just ask saying G to go to search for the best move. So now it's like it's playing itself. 200s and G, and yeah, just playing chess. And so on. Well, not the best ever moves. Well, if I give it a bigger search depth, it would be playing much better. But anyways, so maybe one last. And let's say G. I just want to make a few moves to show you one last trick before I go. Okay, so queen goes to F6. Yeah, with this depth, it's not really balanced because of the horizon effect and hollow the things. But what do you actually want from around 1K chess program written in 6502 assembly? So I did this chess on my own, and well, if it plays with a search depth 3, it plays much better than with the search depth 2, but it takes for about 40 seconds to make a move in the opening, and in the complicated middle game position it takes even more. Anyways, let's just clear the screen for now. Okay, and one more trick. So here, by the way, I've already updated, so we have this clear screen in the README. So we can save the session to the SPI-FFS. So SPI-FFS stands for Serial Port Interface Flash File System. And whatever we have currently in the RAM can be dumped into the file in the binary format. So if I just say F2, it goes for such a weird, strange effect, which I have no idea where it takes the origin from and how to get rid of this. But anyways, now he's done. So save in session, done. And now we can reload, like reboot. And you see, like there is nothing on the board any longer. 200s doesn't have 200s doesn't have anything, etc. And to make it even more brutal, I just power it off from here, and I just power it up back to here, and it uploads again. So now, if I say F3 to load the session, just saying F3, it goes much faster. And now if I say again, like I have a look at 00, you see like we have the board there. We do have the board, and at 200s, we have our search. Yeah, and most interestingly that the game has been stored. So if I go to 3F6 and G, you see we have exactly the board position where I've actually stopped playing. So this is another brand new feature which is possible thankfully to this absolutely fantastic ESP32. So a few words before I end up this video. So only thankfully to Fabrizio Di Vittorio, who's created the FabGL library for this ESP32. This work was actually possible because here I'm using his NC terminal that he's made for ESP32. So all I needed just to bind a couple of functions to output the character and to read the keyboard. That's quite trivial as opposed to the work he has done. And obviously, I want to thank to my friend Dominic Van Beck. Dominic, if you're watching this ESP32 you've sent me this winter is absolutely amazing piece of hardware. So now I feel like I have a computer of my dream, really, and now I think it's just perfect now. So yeah, this is kind of it. So this is it from my side, guys. Thanks for watching. Until the next time, and take care.